When you're executing a parallel link query and then consuming the results, what you're essentially setting up is a parallel producer-consumer pattern. You're just not thinking about it, and because you're not using a blocking collection, you're not so aware of it, but that's exactly what's happening. Because keep in mind that parallel link queries are just execution plans which are delayed. They are lazy. The only instance at which you're getting the results is when you start enumerating them. So the question is, what is the relationship between the items being produced and the items being consumed? Well, let me show you. I'm going to have a bunch of numbers as always. So that's going to be an enumerable range starting from 1 and ending at 20. I'll make an array out of it. And then what I'm going to do is I'm going to do a select on it with the parallelization. So I'll say var results equals numbers.asParallel, and then I'll do a select where I take x, and x is going to go to the following. So I'll calculate the result. That's going to be maybe a log base 10 of the actual value. So let's have that. And then what I'm going to do is right line the result. So I'll say produced, and then the actual result, and then I'll return the result. By the way, that red squiggly was incorrect here. Everything is okay in this code. So this is the parallel producer, and then the consumer looks like this. So you have for each, you're iterating results, for example, you're getting each of the results and you're consuming them. Consumed, and then get the result. So we've seen this before. Let's actually execute this, and I want to show you something. So you can see that we produce some results, and then at some point we start consuming them. We produce and we consume, but you'll notice that the vast majority of the consume calls happen at the end once we've produced all the items. So we produce most of them, we start consuming, we produce the final ones, and then it's like consumed, consumed, consumed all over the place. So what this basically means is that the items which are produced, they are also buffered. What this means is that essentially parallel link, it says, well, I don't want to give you items one by one. I'll put them in like groups of 10 or something, and I'll return them in these kind of lumps. And you can actually control the way that these items are merged together, the way that they are given back to you from the parallel producer. So this is yet another option you can stick in here, and it's called with merge options, but it has to go after as parallel. So with merge options, and let's take a look at what the options actually are. So the default, or the auto buffered, is when the system chooses the values for you. It basically decides how to do the buffering. The fully buffered means that you're not going to get any results until all the results have been produced. And then not buffered, that's an interesting one. This will give you items as soon as they become available. So let's take a look at not buffered. That's interesting. So you can see that we have plenty of consumers happening inside the overall range. Actually, let's do a write instead of a write line. So I'll do a write, and instead of produced, we'll do just a P, and instead of consumed, we'll do a C in here, and I'll put tabs at the end of it so that we can see more of the data and see what's going on here. So I'll put a \T here. So essentially, you can see that we're producing items, but then consumption happens fairly early on, and it's all kind of a mix. So as soon as some of the elements become available, they are given to you. Now, on the other hand, if I were to specify that the thing is fully buffered, we won't have any items consumed until all the items are produced, and that's what you can see here. There are lots of P's, P, 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 and once all the items are done, then it's full of C's. So the merge options essentially let you control how quickly you get your results once they're calculated.